Ladies and gentlemen, hello and welcome, coming to you once again, not quite live from One Take Studios, where today I am recording my 100th video for YouTube this year. Oh my gosh. So, we have Law of Cosines today for our topic, and the biggest thing that I wanted to stress right off the bat is that this works for all triangles. So what I have drawn here is a generic triangle. What I mean is, it could be a right triangle, doesn't have to be. Maybe it's obtuse, maybe it's scalene, maybe it's acute, maybe it's isosceles, whatever. Alright? The most important thing, however, are the labels. Your vertices of your triangle, the corners are going to be capital letters A, B, and C. If you want to put them in a different order, you can, that's fine. Because that's, again, the point is that this works for any triangle, however you label it. But the sides have to be labeled corresponding to the angles across from them. So if angle A is here, then opposite angle A must be side A, opposite angle B must be side B, and opposite angle C must be side B. Side C. And the sides are then labeled in lowercase letters to contrast. So, if that's true, then we have this delightful mess called the Law of Cosines, and ladies and gentlemen, that's it. All of that. What is it? What is it really? Well, honestly, if you see elements of the Pythagorean theorem in there, you're not wrong. This is sort of a strange alteration of Pythagorean theorem adapted so that it works for all triangles and not just right triangles. And the reason that you see 3 lines of stuff here, well, it's not actually 3 lines of stuff. It's one thought written 3 different ways. This says, here's side A, and at the opposite end, here's angle A. So I can find side A if I know the angle across from it and the other 2 sides. What does this say? I can find this side if I know the angle across from it and the other 2 sides. The only reason this is written in 3 parts is to make sure that you understand that it doesn't matter which corner is A or B or C. This is going to work regardless, so long as you have an angle, a side across from it, and the remaining sides. Okay, so decorate that so that you can find it easily in your notes. Yay, pink pen, celebration, party zone, decoration, there we go. That is Law of Cosines, know it, love it. You're probably not going to have it memorized right off the bat, which is fine. So please make sure that you do consult your notes so that you don't lose a sign or anything crazy like that. I want to show you 2 cases of problems that we might solve using Law of Cosines. And so this is our first case today. This is the side angle side case. If you're thinking, side angle side, that sounds like a theorem for proving triangles congruent in geometry. That's because that is. Alright, you can use side angle side to prove triangles congruent in geometry because this particular data set in this arrangement will always and only create one triangle. So in other words, if I've got part of the data from this triangle in this particular pattern, 2 sides with the angle between them, I will be able to make one triangle and one triangle only. So we're not doing proofs. Chill, it's okay. Some of you have trauma from proofs, it's okay. But because this was used for proofs, it actually makes our life better and easier. So I'm going to start by drawing a generic triangle. Oh no, it's messy. I don't care. It's not drawn to scale. Whatever. I'm using this as a data organizer to see what I have. I know that angle C over here, 32.2. Squeeze that in there, and then the side B, this is going to be 5, side A is 8, and oh, check it out, I can easily see now that I've got the side and the angle and the side, so I can see this relationship here. It also tells me what I have and what I don't have. Let's see, I need to find, if I'm solving a triangle, I need to find all the missing parts, so I'm missing one side and 2 angles. I can't find the missing side, because it's probably not a right triangle. I can't assume that's a Pythagorean theorem. That's out of the question. I can't use Law of Sines, which I've used previously, because I don't have a pair of A's, B's, or C's. I do not have any sides with angles across from them. What can I do? Well, guess what? I could find this side because I know the angle across from it and the other 2 sides. So that's where I'm going to set out today, is by finding side C. So that is a lowercase c squared is equal to, I'm using this guy right here because we're saying I have side A, that's going to be 8 squared, plus I've got side B, which is 5, that'll be 5 squared, minus 2 times 8 times 5 times the cosine, that is not a c, times the cosine of 32.2 degrees. How does this work? Exactly as you see it. All you got to do is be careful. and I really do mean you've got to be careful with this. All right, order of operations, that's still a thing, and that's a very, very real thing. So can I type this in all at once? Will I type it in all at once? Why not, I suppose. So we are talking 8 squared plus 5 squared minus 2 times 8 times 5 times the cosine of 32.2 degrees. My calculator is in degrees. You might want to make sure that your calculator is doing the same. And that gives us this lovely number here. Ooh, there we go. 21.3045. So c squared, squared, is approximately 21.3045. Why am I not rounding this yet? Because the calculator will hold as many decimal places as I need for it to hold, and I'd like for my answer to be as accurate as possible. So when I go to find c instead of c squared, in other words, when I go to take the square root, I'm going to do square root, and then I'm going to run up and grab this number that the calculator has stored in all of its glory. That way I can maintain the most accurate answer possible, and I find that c has an approximate value of 4.62. 4.62. Why did I round to 4.62? I'm using a rounding method that says, hey, you should round sides to 3 significant digits. If you like that, great. If you don't like that, no, I won't hold it against you. So there we go. That's 4.62. That is this side right here. 4.62. Are we done yet? Of course not. If we're solving the triangle, we are still missing 2 angles. We have all 3 sides, but we're missing 2 angles. But now we actually have a pair. The pair that I was referring to before that we didn't have, we have side C and angle C. We have a pair of C's, and we can use that. So we are talking the sine of 32.2 degrees over 4.62. Yes, sadly, we do need to use the rounded value here. You're welcome to use the calculator to try to get more decimal places with that if you like. Equals, what are we going to find? We've got 2 angles left to find. We need angle A and angle B. Can I make a recommendation to you? Do you promise to listen to me? Here we go. When you have more than one angle to find, always try to find the smallest angle first. 5 is smaller than 8, so the angle across from 5 will be smaller than the angle across from 8. So I'm going to go with the sine of B over 5. Why does it matter? Why am I going after the smaller of the 2 remaining angles? We're going to have to use inverse sine to find angle B. If we're going to use inverse sine, what does the calculator always do? It always gives us the value closest to 0. It will always give us a smaller angle. So if I go after a large angle that's actually obtuse, but I don't know it, and the calculator gives me an acute angle, I'm going to be wrong, and I'm going to have no clue that I'm wrong. But if you always go after the smallest angle first, you will never be wrong. And you don't even have to worry about falling into a trap that you can't see. So always pursue the smallest missing angle first, and you will never accidentally be wrong. Again, with cross multiplying here, I'm going to go with 5 times the sine of 32.2, the sine of 32.2, and that's going to be divided by 4.62. All right, so what do I know right now? Through cross multiplication, I know that the sine of B is equal to approximately 0.5767 blah blah blah. And again, that is an approximate value, not an exact value. But to find B, how do I undo sine to get the B by itself? I use the inverse sine. So here's my inverse sine of that value that I just found. All right, so calculator close up, there we go. There you go. Can you see that? So I did my cross multiplying, the divided, I got this value. I'm going to go with the inverse sine of the value that I just found right there. There we go. To give me, dun dun dun, 35.2. And actually that's what I'm going to round. I'm going to call it 35.2. I'm going to round my angle to the nearest tenth. So B is approximately 35.2 degrees. Right there. All right. So 35.2 degrees. Excellent, excellent. Am I done? No, but I am oh so close. I am just missing one angle, and while I could use law of sines or law of cosines again if I wanted to, I don't really want to because I know that 180 degrees total makes a triangle, minus the 32.2 that they gave us to begin with, minus the 35.2 that I just found. Whatever's left is going to have to be my third angle. So again, 180 minus 32.2 minus 35.2 equals, wow, that says 1980. Nope. One Take Studios, people. Here we go. Minus 35.2. How about 112.6? That sounds nice, doesn't it? Yes. 112.6 degrees. And that's going to be our missing angle, angle A. Guys, we just averted disaster. Did you catch that? If we had gone after angle A first, the calculator would have given us something that was acute instead of obtuse, and we would be completely wrong right now, and we wouldn't have a single clue that we are wrong. But because we went after the smallest angle first, we are victorious. There we go. There's our missing information right there. All right, ta-da! One case down, one case to go, and then I promise to leave you alone. Here we go. This is it. This is the side case. Again, a theorem that was used to prove triangles congruent, which benefits us because that means it's going to make one triangle and one triangle only. And our given information, of course, then is going to be all three side lengths. Which, if you'll notice, again, does not give us a pair. We don't have an angle and a side across from it sort of thing. So law of sines, again, is off the table. Am I drawing this to scale? No. Do I care? No. I'm just using this to set up and organize my thoughts here. That's going to be a 9. That's going to be a 7. All right. So what can I do? These formulas have 3 sides and an angle. If I have 3 sides, logically that means I could find an angle. Which angle should I find? Well, let's see. 7 is the smallest side, thus C is the smallest angle. I'm going to go after angle C first so I don't walk into a trap because, again, the calculator always gives me the smallest answer when I go to do inverse to get that C by itself. So I'm going to go with this guy right here. So C squared, that's going to be 7 squared. 7 squared equals, this is going to be 8 squared plus 9 squared minus 2 times 8 times 9 times the cosine of C, and we will be solving for C. All right, law of cosines. Like this, not too difficult. Just jam it all in the calculator, take the square root, call it good. Law of cosines like this, people make mistakes all the time, because again, order of operations is a thing. So do what you can do, but be very, very careful, all right? So we are talking, this is going to be 49 is equal to, that's 64 plus 81 minus 2 times 8 times 9, which I can probably do in my head, but I don't want to embarrass myself at the moment. That's going to be 144, and then that's times the cosine of C. I'm going to write this all out so that you can see it, but I won't write it out every single time because I just want you to see this. What is possible here? Some of you right now want to do 64 plus 81 minus 144, and that is illegal because this 144 is being multiplied. So until you multiply this, you can't combine it with the other ones. These two, these are like terms. If you want to put those together, great, go for it. So 49 equals 64 plus 81, which is 145, so equals 145 minus 144. Again, that's tempting, but you can't actually subtract it because of the multiplication that's sitting here. So then what can you do? Work on getting C by itself. Subtract the 145. What is 49 minus 145? That's going to be negative 96. So negative 96 now equals, watch your negative, negative 144 times the cosine of C. Do I have C by itself? Not yet, but I'm getting closer. So I'm going to keep working at that. I'm going to divide. So whatever negative 96 divided by negative 144 is, that's going to give me the cosine of C, which gets me so close to having C by itself, but not yet. Again, how do I undo cosine? With inverse cosine. So I'm taking the inverse cosine of this mess right here. So C will equal the inverse cosine of whatever 96 over 144 happens to be. So survey says inverse cosine of 96 divided by 144 is 48.2. So C has an approximate value of 48.2 degrees. All right, there we go. Ta-da! That was so exciting, we should do something else. Should we do the same thing again? We could. Absolutely, we could do the same thing again. The problem with that is that a lot of people don't like to recreate this more times than they have to. And the good news is that now we have angle C. And since we have angle C and we've got side C, we have a pair. So law of sines now becomes a viable option again. I'm going to squeeze that right over here. I'm going to go with the sine of 48.2 degrees over, that was angle C, so side C is 7, equals, which angle should I find next? Well, which is the next smallest side? 8, so I'm going to find angle A next. So sine of angle A over 8. I'm not going to write out, excuse me, all the work on this one, but I will punch it out here for those of you that want to see it in the calculator. We're talking cross multiplying 8 times the sine of 48.2 degrees divided by 7, and that gets us the sine of A, but we need to do the inverse sine to get rid of it. So we're doing the inverse sine of everything that we just did. Boom and boom. There we go. Close up for those of you that are looking at what I just did. So cross multiply, divide by 7, inverse sine, 58.4 degrees is our new number. So there's angle A at 58.4 degrees. And then there's much rejoicing because now I've got 2 out of 3 angles. And to find the third angle, again, is essentially a walk in the park. I've got 180 degrees total in my triangle, minus the one angle that was 48.2, minus the other angle that was 58.4. Where does that leave me? Hopefully, that leaves me with, let's see, that's A, so B is going to be 73.4. 73.4, do I believe that? I'm pretty sure I believe that is angle C. There we go. Nope, I just said angle B. Angle B, not angle C. All right, and that's it. So that is 2 ways that you might possibly end up using law of cosines. Based on your given information, you can't start with law of sines, so these are good options to have. 73.4 degrees, there we go. All right, so careful, watch your order of operations, be patient, be organized, and you can do this. All right, enjoy.